Hello, this is Dennis with A1 Telephone Service and Repair, A1 Electronics. You can get us on the web at www.a1-telephone.com, and you can also reach us at 618-235-6959. Today I want to show you more or less known as like a kitchen wall phone. It's a Western Electric 255 or 255-4. And Tony sent this in from California. And basically, the customer complains of not being able to dial out. So basically, to show you that we've got hook switch here, and we're getting a line, I'm going to start trying to dial on the phone. And sure enough, it doesn't dial. But it's not always like that. And I'm going to explain a little bit of what's going on here and give you a little look on the inside of this telephone. This is an AT&T telephone, and it's made by Western Electric, and this is back when these telephones still have some really great quality. These were a very good telephone, and that's why they're still around. And so basically, anyway, to get into the telephone, I already have the keypad loose. I want to show you that real quick. Tony was maybe figuring that his keypad was bad, and that that might be the problem, and to take it apart and try to repair it could really, I'll show you, see, it's not dialing out. Well, that's not always the way it is, though. I've got a feeling here that what we have here is, I get calls from time to time. People say, I've got this little orange box in my telephone. Do you know what it is? Well, sure. It's a bridge rectifier. And the actual bridge rectifier is this little IC chip right here. Okay, and it's a circuit that they came up with that's kind of an overkill circuit. It's a bridge rectifier, and it has some other components on it, some resistors and another diode and that. And basically it's to keep the polarity proper on the telephone. Well, when you have dialing problems, it's because you don't have you have a polarity issue, is basically what it comes down to. And there may or may not be a bridge rectifier circuit in the telephone of this age. This one just happens to have one. So when Tony tells me that he can't dial out, this is our culprit right here. So basically, I'm going to build another bridge rectifier and stick it in this little orange box, and take this bridge rectifier circuit out. There's no need for these resistors in here, really, and I'll tell you why. You have to, he's in California and I'm in the Midwest, so I'm not sure what his line voltage is doing out there. It may be fluctuating. So basically with this circuit here, if it's failing, it could be the bridge rectifier, but it also could be, if he's got a fluctuation in voltage on the line, these resistors are basically to pull voltage down and up the current. So that's what a resistor is basically used for. And we have enough current, and if it's fluctuating, I mean enough voltage, if it's fluctuating, this is pulling it down even more, and under the right conditions it may be making the bridge rectifier fail. The bridge rectifier could be failing on its own, and so could this other diode here that they've put in the circuit. But without testing this phone or keeping an eye on it and putting test equipment on it under the conditions that it's being used in, you have to kind of think ahead. And so anyway, basically it's most likely the culprit. When you can't dial out, it's going to be a bridge rectifier issue. Sometimes it can be the keypad. but in this case, this keypad will dial fine. And so anyway, what we want to do here is we want to remove this bridge rectifier circuit, and I like to build my own. I always have, and it's a lot more fun. So you could go out and buy one of these bridge rectifiers, but it's easier and simpler just to make your own. And I have for many years now. So that's what we're going to do. And without the rest of this circuit in the situation when we build the bridge rectifier, we won't have to worry so much about his voltage fluctuations on the line, because I'm not there to be able to test the line, so I don't know what's going on. But somewhere we're getting a failure, and it could be because of low voltage coming in, fluctuations, and this bridge rectifier could also just be going bad, this circuit. So it's failing, and we're going to build another one and get him squared away. These were really good telephones. This gives you some kind of a look at what we have in this telephone and how they designed it. And it was a really very good telephone. And you don't get quality like this any longer, that's for sure. You just can't find these phones anymore when you go to buy a phone of this quality. So you basically have to repair the old. And that's a pretty wise decision, because you would never get a telephone of the quality that this Western Electric is. And I'm going to do a second video of this telephone once we've repaired it, and we'll go from there. And that way we won't have to worry about any polarity issues, we won't have to worry about this bridge rectifier failing, and we won't have to worry about the new bridge rectifier being choked out, because that's exactly, if they're fluctuating the voltage, and these resistors are basically designed to lower your voltage but up your current, and we don't need no more current. We need the proper voltage so everything works properly. So we don't need that part of this circuit, and it's not going to help us any to have it in there in case he does have certain fluctuations on his line. So anyway, we'll do another video of this telephone when we finish up, and we'll show you basically the bridge rectifier that we make and put in it, and then we'll go from there. There is some configuration to the lines. You have to know where your connections are supposed to be made on a bridge rectifier, so it's not like you know, you can just build one and throw it in. You have to know how to configure it. So once you do that, you know, you can solve that problem. Thank you for watching. I hope you enjoyed it. This is Dennis with A1 Telephone Service and Repair, A1 Electronics. You can get us on the web at www.a1-telephone.com, and you can also reach us at 618-235-6959. Thank you for watching, and have a great day.